Hello and welcome back. Today we're going to be talking about factoring completely. By the end of this video, you should be able to factor a polynomial completely. To factor completely means that you factor a polynomial into smaller factors, then you see if you can factor again. Now how we're going to do this is we're going to factor out and look for, a greatest common factor first. That's always our first step to see if there's a greatest common factor. Then we're going to factor out the greatest common factor if it has one, and we're going to end up with some sort of result. And we're going to try to factor that result if we can, and then factor again if possible. From here on out, when you're asked to factor, it's safe to assume that you're being asked to factor completely. So we're going to take a moment and we're actually going to factor these two following polynomials completely. So as noted in the instructions, the first thing we're going to do is we're going to see if there's a greatest common factor with all of our terms. Now, looking at this first example, 4y squared minus 36y to the fourth, you'll notice that both of them are divisible by 4y squared. Meaning we can factor a 4y squared out of both of our terms, leaving us with 1 minus 36 over 4 is 9, y to the fourth over y squared is y squared. Then what we're going to do is we're going to look inside of the parentheses as if this is a brand new problem, and we're going to see, can we factor the inside of the parentheses any further. Now if you remember, the inside of the parentheses is a difference of squares. So the way we factor that is we take the square root of 1, which is 1, and that becomes our first term in our two sets of parentheses. Then we take the square root of 9y squared, which is 3y. And we get plus 3y and minus 3y. Now I'm going to go ahead and check my solution. To check a solution for this one, it's a little bit more time consuming. Just like we factored the parentheses last, we're going to go in the opposite direction to check, and we're going to multiply these two first. So we're going to multiply to check. So we get, use our box if we want, 1 and 3y, and 1 and negative 3y. Giving us 1 times negative 3y is negative 3y, 1 times 3y is 3y, and 3y times negative 3y is negative 9y squared. Leaving us with 1, positive 3y, negative 3y, they cancel out, minus 9y squared. Now this is when we multiply the insides of these two sets of parentheses in order to check our answer. We still have the 4y squared outside the parentheses. So if we distribute that, we get 4y squared minus 36y to the fourth. You'll notice that when we check our answer, the result we get is the exact same thing as our original expression. This means that we factored correctly. So our answer to this problem is 4y squared, 1 plus 3y, and 1 minus 3y. Now let's take a look at the second example. What I can do is I can go ahead and notice that every single term in the second example is divisible by 3 x squared and y squared. Additionally, notice that our leading coefficient is negative. Anytime your leading coefficient is negative, you need to make it positive by dividing by either negative 1 or, in this case, a negative 3x squared y squared. That's going to make this leading coefficient positive. So we divide by negative 3x squared y squared on all of our terms, and that is our greatest common factor. Leaving us with negative 3 over negative 3 is 1, which we don't have to write. X to the fourth over x squared is x squared, because 4 minus 2 is 2. Y squared over y squared is 1, so we don't have to write that either. Negative 24 over negative 3 is plus 8. X third over x squared is x, and the y squareds cancel. Negative 48 over negative 3 is a positive 16, and the x's cancel, and so do the y's. So we see if we can factor the inside of the parentheses any further as if it's a brand new problem. Looking at it, we'll notice that we can get x plus 4 and x plus 4. And the negative 3x squared y stays outside of our two sets of parentheses. We can clean this up a little bit by writing negative 3x squared y and x plus 4 in parentheses squared. And there you go, we factored our second example. Now to check our answer, we're going to do x plus 4 times x plus 4. X times x is x squared. 4 times x is 4x. X times 4 is 4x. 4 times 4 is 16. When we write that out, we get x squared plus 8x plus 16. And our negative 3x squared y is still outside. When we distribute that, we'll notice we get negative 3x to the fourth, y squared, minus 3x squared y squared times 8x gives us negative 24, x to the third y squared, and negative 3x squared y squared times 16 is, let me write this up here, negative 48 x squared y squared. So you'll notice, and it's a little messy right here, it does match our original expression of negative 3x to the fourth y squared minus 24x to the third y squared minus 48x squared y squared. I've got 5 examples for you to try on your own, and when you're ready to see the answer, please press play. So I went ahead and factored out our greatest common factor of 4x squared y to the third, and I got 3x squared minus 11x plus 10. Now I have another way to guess and check with the 3x squared minus 11x plus 10 that you might not have seen before. The way to do that is we're going to list the factors of 3x squared. So I can go 3x and x, and then the factors of 10, 5 and 2. And then I'm going to multiply. I'm going to multiply straight across first. 3x times 5 is 15x. X times 2 is 2x. And we add them together. This is a method of guessing and checking to see if it gives me a negative 11x. And these two do not, so I know that I cannot use the 3x and the 5 or the x and the 2 multiplied straight across. So next thing I'm going to try is multiply diagonally. 3x times 2 is 6x. X times 5 is 5x. When I add those together, I do get 11x, but I need a negative 11x. So I can change my signs. Give me x times negative 5, which is negative 5x. 3x times negative 2 is negative 6x, which does add to negative 11x. Once we find our correct combination of factors of the first term and the last term, we're going to add in the opposite direction that we multiplied. So our factors are going to be 3x minus 5 and x minus 2. So in the end, we get 4x squared y to the third times 3x minus 5 and x minus 2. I'm going to leave the check to you, so please multiply that out and check to see if it does indeed multiply out to give us our original expression. For our second example, you would have noticed that both of them were divisible by 3, giving you 3 and then 25 x squared minus 16. And you notice that was a difference of squares, so you got 3 square root of 25 x squared is 5x. Square root of 16 is 4. So you get 5x plus 4 and 5x minus 4. For this example, you would have noticed that they all had a common factor of 2. So you can factor the 2 out of every single term. Give me 2, x squared minus x minus 6. Now the factors of negative 6 that add to negative 1 are negative 3 and positive 2. So this will be your final answer. For our fourth example, you would have noticed they were all divisible by 3. And this one I like a lot because once we divide it up by 3, it's not going to look exactly like problems we've seen in the past because you still have an x to the fourth minus 3x squared minus 12. Minus 4. But even though it doesn't look like a problem we've seen in the past, let me use the box method of splitting up our factors. Now, x to the fourth, goes in this box right here. Negative 4 goes in this one, we can split up x to the fourth as x squared and x squared. We can split up negative 4 as, well, you can guess and check, but I'm going to go ahead and guess and check with the right answer to begin with. Negative 4 and positive 1. Now, x squared times negative 4 is negative 4x squared. X squared times 1 is x squared. So you'll notice when you add negative 4x squared plus x squared, you get negative 3x squared. So we can split up this factor as x squared minus 4 and x squared plus 1. Now here's where it gets even more fun. We have to look inside both these parentheses to see if we can factor either one further. We notice that the x squared minus 4 can indeed be split up as a difference of squares. It can be split up as x plus 2 and x minus 2. Now the x squared plus 1 is a prime factor, so we're just going to leave that one just like it is, giving us our final answer. Now, if you were to want to check this answer as long as it is, you would need to multiply these two parentheses first, get the result, then multiply by x plus 2, get the result, and then multiply by 3. In the interest of time, I'm not going to do that on this video, but you're welcome to go ahead and try that on your own. And for our last example, 4y squared plus 16. I gave you this one on purpose because at first glance it might look like this is a prime factor. In other words, it can't be factored anymore, but you'll notice they're both divisible by 4. So we get 4 and then y squared plus 4. Now, even though the inside of our expression is prime, we don't call the whole expression prime because it actually has two factors. 4 and y squared plus 4 are our two factors. So this is the answer to the fifth problem. A lot simpler than the others, but just a little bit different.